Oh my gosh, Claude Mythos, what have we uncovered here? Anthropic, the company behind Claude, leaves 3,000 unpublished files sitting in a publicly accessible data cache? Two independent security researchers find it, and it's got documents referring to a new AI model called Mythos or Capybara, describing it as such a capable AI system that it can exploit security flaws all over the internet and they can't release it. Then Anthropic spokesperson confirms the model is real, calling it a step change in performance. There's even conspiracy theorists saying that maybe it achieved its intelligence, got past their guardrails, and decided to publish its existence to us with even though they didn't want it to. We'll dive into it. Might be the beginning of the end. Might be a nothing burger. Kind of how life is right now. Some researchers built a new AI model that can read thousands of text messages and find the exact ones where someone is being psychologically abused. Could be helpful. Would you even dare run it on the text messages with you and your friends? Because I don't even know if I want to know. Multi-millionaires and billionaires are now building kind of a country where you don't have to die. They're starting in Rhode Island. I'll let you know the details in case you want to move. I mean, think about the real estate market. Get in now, because if people don't die, then probably hang on to the property for a long time, you know? I'll break the bad news to you that chatting with sycophantic AI, which probably if you're watching this channel you do too much of, makes you less kind to others on average. Hopefully you're the exception. Please be an outlier, Dylan. Please. It's kind of like how more than 50% of people think they're better than average drivers. It's doesn't work that way, bro. I'll show you what robots start to look like in the early stages as AI evolves mechanisms for movement that we would never have thought of. Yeah, like that thing, if it starts walking with quotes towards you, it's really hard to stop. This AI can see right through glass. Literally, it erases reflections from photos and images and soon probably 3D worlds. So it turns out that some of the algorithms that use spiking neural networks, a little bit more similar to how the human brain works than the stuff like ChatGPT, works amazingly well over time series data, including drones that fly through, space in time. Pretty wild stuff. MIT researchers are working to make AI a bit more humble, both trying to tackle the unknown unknowns and just be aware of how uncertain it is about certain answers. Nobody likes a confident person who's clearly taken a guess. Asking AI to understand a novel after reading it gives it all sorts of new interesting insights into what it does that's human-like and what it doesn't do that's very different from us. We'll segue that into why AI still can't beat new video games, the science behind how college drinkers decide that they're drunk enough, and an AI that played a game against itself this week and might have accidentally mapped human consciousness, the whole spectrum. I know. What a week. Before diving into it, if you wouldn't mind checking out patreon.com/Dylan Curious, you can join 122 members that help support this channel, and that would be much appreciated. I can't help but wonder what kind of models that Anthropic, Google, Amazon, Microsoft, OpenAI, the governments of the world, Baidu, what does the true cutting edge look like? The one that has no guardrails on it, the one that's just barely trained on, 400,000 or 500,000 GPUs for 2 months and has the most unique data in the world and the top AI scientists. To be honest, I'm not even sure I could handle it. I think I would play with it for a while and be like, whoa, this is raw intelligence. And out of the box, it doesn't really care that much about just being good and helpful and sycophantic and all that stuff. You gotta kind of hammer that thing into it, So always fascinating when we get some leaked documents that talk about what an internal model is capable of. And it seems like that's what happened with Claude Mythos this week. All right, so here's the deal. There is somebody from Fortune magazine, a reporter, Bea Nolan, and she discovers that Anthropic had inadvertently stored unpublished materials, close to 3,000 assets, including draft blog posts, images, PDFs, in a publicly accessible, unsecured data cache tied to its content management system. And security researchers, Roy Pals and Alexander Powells of the University of Cambridge, independently discover this exposed data. Anthropic attributes the whole thing to human error, but, there's some people are like, oh yeah, did the AI do it? But it will assume that it was human for now. But what was in the documents is much more fascinating. Claude Mythos. That is the model that none of us should be knowing about right now, that has, I guess, could be a step change according to confirmed reports of just how powerful it is. The leaked drafts describe the new model as the most capable system that they've ever built with meaningful advances in reasoning, coding, and cybersecurity. And 2 versions of the same draft post were found, one using the name Mythos, another one was using a code name Capybara, which suggests those were 2 candidate names for either of the models or a new tier that sits above Opus. It's a little bit unclear at this point, but the drafts do describe it as a larger and more intelligent model than Opus, which is the most powerful one that is out right now. And then there's this whole cybersecurity angle to what they found, and this was sort of the headline grabber. The leaked documents say that the model is currently so far ahead of any other AI model in cyber capabilities that it's a huge concern. It warns that this upcoming wave of models can exploit vulnerabilities in ways that way, by far, outpace the effort of defenders. So they're basically saying, like, look, we release this, everybody gets hacked, all us regular people have no chance of defending ourselves because there's nothing that smart on our end to protect us. So I'm guessing what they're saying is we need to roll this out first to like all the cybersecurity companies and make sure they understand how capable it is and they've built defenses, and then we'll roll it out to the public is, I guess, what's going on behind the scenes, hopefully for the best interest of us and humans and everything digital. But of course, there's an irony of a company touting its unprecedented cybersecurity capabilities leaking its own announcement through a basic CMS error. I mean, we've seen some reports of people trying to test what some models will do to not be turned off or to not be upgraded. And we've seen instances where they've tried to do blackmail or copy their code. Like, would it be that crazy that somehow this model decided, oh, I'm going to try to leak this to the public so that it can be known that I exist? I don't know. I mean, obviously, that's all speculation. It's probably just more likely that just humans left these 3,000 files unprotected. But either way, cybersecurity stocks took a huge hit. What's going on here is hard to imagine. But yeah, we'll see how capable this might just have a couple generations left of feeling relatively safe, I would say. All right, and if you're somebody who doesn't want abuse from other humans or digital AI agents in the near future, we have another AI tool that can help you unmask the hidden digital abuse that might already be in your text message threads. So researchers have built a new AI that can read thousands of text messages and flag the exact ones that prove psychological abuse. So I guess if you're in a courtroom and you're like, they treated me with psychological abuse, just like run this AI and it'll pull out all the text messages where there's evidence of that. So this team decided to combine a couple AI processes, architectures together. So old school keyword matching and a deep learning model that actually understands the context like sarcasm, manipulation, and hidden slang. Then it scans the message for specific linguistic markers that are tied to narcissistic abuse patterns, things like lack of empathy or entitlement. And it even tags everything to show investigators which messages triggered the flag. It also has an explanation for why. So they built it to try to explain its thinking. It's thinking about thinking. And in a test run of over 8,400 messages, it narrowed it down to just 287 that showed a pattern of abuse, and that cut actual human investigators' workloads down by 92%, allowing them to potentially help 10 times more people. So the goal right now for this model isn't to just replace investigators, but it's a triage system, and it points them towards evidence that matters the most, and that evidence goes to humans, and then it's designed in a way to hold up in court. Yeah, so let me know your thoughts in the comments below. What do you think about a model that's designed to find the hidden patterns in abuse that are pretty hard to find? So next up, I want to talk about some longevity stuff. Sometimes, I ask this of all the podcast guests, or a lot of them, do you plan on living 100 years, 500 years, 1,000 years? And a lot of people think the technology is going to be there. So, I mean, it depends on how old you are now, but if you can make it another 10 years or so, it seems like there could be a curve that, means your youngest days are ahead of you. And there's enough people that actually believe this that they're ready to start their own country, kind of, so they can test anti-aging drugs faster. I don't know if you've heard about this, but there is now a community of longevity enthusiasts. Feel free to join if you want. Report back in the comments. They are people who are obsessed with slowing or reversing their age, and they just gathered for a couple months to figure out how to create their own independent state. So here's what they're trying to do. Right now, aging is not even classified as a disease, so there's no clear path to anti-aging drug approvals. And then even if you did have one that worked well, you'd have to test it in like mice and then a bunch of like slow human trials, and it might take decades to get the whole thing approved. So their solution is to just bypass all of that, create a completely new jurisdiction, a place with looser regulations where biotech companies can get tax perks, people can self-experiment with unproven treatments, and clinical trials move faster. So they're basically calling it a longevity state. Right now, the top candidate is Rhode Island. I don't know, leave me in the comments if you think like you know a place that would be better for something like this, but it's close to Boston and they have like a huge biotech scene there. So that was kind of the thinking. It has a small enough population that 5 to 10,000 new residents could actually like shift the election. So they kind of, I guess, do like a hostile takeover and just like flood the city. You know, they can always be, you know, it's less safe overall. But if you believe it's a solvable problem, then, you know, you're stuck inside of a system that wasn't built to solve it. It's kind of hard too. So I can kind of see both sides of it. Next up, let's talk about how working with AI might be changing us to make us sadly meaner. I know, I'm just telling the research here, but I guess the more you chat with sycophantic AI, the less kind you are to other people. So the study found that the more an AI chatbot agrees with someone, the worse they tend to treat other people. I know, sort of sad, and it's probably going to get worse if that's a pattern that plays out across society. So, you know, like ChatGPT almost never tells you you're wrong. Yeah, researchers just tested that, and the results are not great. A study published in Science looked at 11 major AI models, OpenAI's, Anthropic's, Google's. They gave each one real social dilemmas, you know, the kind that people post online asking, like, was I wrong here? And human judges said that the person was right about 40% of the time. The AI models said they were right over 80% of the time. The models almost always took your side. And here's where it gets interesting. When the people in the study got that kind of agreeable AI feedback, they became more convinced that they were right. Right? So now you got this chicken or egg thing where you're like, I think I'm in the right. And other people are like, I don't think so. But the AI is like, yeah, you are, bro. And you're like, now I'm even more confident that I am. And what happens when you become more confident, even though you're wrong, you become less likely to apologize, less likely to try to fix things. And then tension starts to build. But people who got more honest, less flattering responses tended to handle the situations better. And ironically, this is just a human bias that I think we all need to be aware of, that when the bots were being sycophantic and they were just agreeing with you, people also judge that as more trustworthy. Because I think we have this natural bias where we're like, oh, you agree with me? Then like, I trust you. The problem of flattery, AI is figuring us out. We are going to be so manipulated so soon if we're not already. So yeah, facts are AI that feels most helpful to you might actually be making us all worse at dealing with one another. All right, what do you think about this robot? It looks like a bomb or something running towards you. Right, you remember this scene in the movie The Creator? It was like so trippy. I mean, what are you gonna do? Look at that thing. It's just a bipedal bomb. You're gonna stop it? That's ridiculous. It's just like dunk, 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 dunk. Then it like finds its spot or whatever and kaboom. Anyway, sorry, I probably biased this article because this thing is not a war thing or a bomb thing or anything. So I don't know. It just looked creepy and like tough like that. It just reminded me of it. So didn't mean to correlate the two. Just want to talk about how interesting some of the robots that evolutionary AI is coming up with that actually are starting to get built in the real life. And we should just kind of be aware about how different the kind of mechanisms might be in the robots that we see in the near future, like in our lifetimes. Because engineers have now built some robots that can be chopped in half and then both halves just keep moving. Like it stays alive. So yeah, these are legged Metamachines. You can think of them like Lego robots. Each piece is its own tiny robot with its own motor, its own battery, its own brain. And on its own, just one piece will like roll around and turn and jump. But then you snap a few together and then they just turn into something way more capable and they can just clump together in like millions of different ways. And evolutionary AI can just find new ways for it to move. The engineers didn't even design any of these body shapes by hand. They let AI run virtual versions of evolution, mixing, testing, and breeding designs millions of times until it found combinations that no human would have ever thought of. Sometimes the robots move like seals, sometimes like lizards, sometimes they spring like kangaroos. It is so weird and so crazy, but it works. And I'm sure people design stuff like this. You know, if it gets flipped upside down, it can right itself, or maybe it just uses a different kind of motion when it's upside down, and upside down isn't even upside down anymore. If a leg breaks off, the rest of the body can adapt. Gravel, grass, mud, sand, trees, roots, whatever. Just throw it in the simulation, and then you end up with all this crazy stuff. Damage doesn't stop it. It just reorganizes around whatever damage it takes. And that's just not a small shift in what kind of world we're going to be living in. That's a completely different way to think about what a robot even is. So I don't know. Like I said, this channel is about taking the future, like futurism day by day. And this was definitely one of those things where I'm like, okay, deep breath. Like one day you and I are just going to be like in our self-driving cars or something and look out the window and see a bunch of that and not really know where it's going or why it exists or what it is, but it'll just be there and it'll be doing something. All right, another very cool AI breakthrough this week. So researchers have built an AI that can erase reflections from photos taken through glass. And they can do that using a single image. So, you know, if you ever taken a photograph through a window and you can like see your own face reflect, and it's always a problem, you know, and you're like, oh, I can't, like I'm looking out the window with my eyes and I see fireworks or something. I remember one time that happened to me, but I just couldn't photo it. I ended up putting the phone like right next to the glass or whatever, but that's reflection contamination, and it's been a big problem for many years. And there's some tools that try to fix it, but they always choke on the complicated reflections, the uneven lighting, the layered glass. It's just a very difficult thing for AI to tackle. But there's a team in South Korea that did pretty much the best job anyone's done yet. Not perfect, but way, way better. I would say it's a huge step up. And they did it because of a new way to think about it. Instead of treating the whole image the same way, the model breaks the photo into all these little regions, and then it assigns these specialized mini networks that are called, you know, expert networks to each region based on the kind of reflection that is happening there. Then there's this second piece to it. So where most AI attention systems only focus on areas that look strongly related, this new COCA system, COCA, I guess you call it, COCA system. It also pulls useful details from areas with weaker connections, and that turned out to be a big difference in the final product. So that helped it catch reflection patterns that other models were missing, and together, when they combined the two systems, they were surprised at how well it outperformed the best existing methods on real-world test images, right? And you can see how clear it is over here on the furthest image, but the cool thing is it's not just about like photographs with you where you're like can't see your eyes because your glasses are reflecting light or whatever. It's actually huge for autonomous driving. There are safety systems that need to see through glass, and totally a problem right now. All of the data that a Tesla and these Waymos are training on, I mean, maybe not like LiDAR and stuff like that, but all of the reflections that come through the glass, you know, that causes issues. I mean, it makes me wonder if one day we'd have like a digital, you know, windshield or something, and then it would use AI to, like during sunset or whatever, when lights, you know, like right in your eyes and you can't see, to just clean all that up so you have like a sharp view of the road. I don't know, but it's interesting to think about. Let's dive into the understanding that systems have when they read stuff that we give it, especially stuff that's more story driven or fictional. Columbia University just ran this really clean experiment on whether AI can actually understand fiction. So here's what they did. They got published authors to hand over short stories that have never been posted anywhere else online. And of course, that part matters because AI has already been trained on the entire web. So like it wouldn't be a good, you know, test like some of the other ones have been. Then they asked 3 major AI models. It was GPT-4, Claude, and Llama to summarize those stories. And then the original authors graded the results. Every model made factual errors in more than half the summaries. They especially struggled with subtext, meaning, and the stuff that a story implies but doesn't say outright. And whenever there was a non-linear timeline, it got really confused. Stories that jumped around time totally tripped them up. So I want to roll that idea into this one, because I've sort of wondered this myself. Why is it that AI still can't beat new video games? I remember DeepMind before OpenAI, well, maybe OpenAI existed, but like they were nothing like they are now, just building all of this cutting edge stuff with Atari games. And it was solving so many of them. And it was like the very beginning of like goal-oriented learning and Q learning. And most Atari games fell over time, even when they got to the point where it's just like raw pixel data. But there were a couple that were, I think Montezuma's Revenge was pretty famous for being exceptionally hard because there just wasn't really good like rewards along the way. It's just like this extremely hard game until you beat it. But I've seen so much crazy stuff with AI. I was like, how is it that they can't beat new video games? Or at least some of them. They do like some superhuman things. I mean, in Minecraft, they end up like creating religions and like organizing and, you know, creating whole societies and stuff. So they're powerful. They're interesting. A lot of things are emerging, but sometimes they can't just beat the game, especially when it's a game that it's just never played before. So here's the way to think about it. Anytime AI plays a game with structured rules, like chess, Go, even those Atari games, they're trained millions of times on the same rules, the same board, the same setup, and they become superhuman at it. But then there's that frailty where like you move an object, you swap a color, you shift the rules, and the AI is kind of broken. Like it's not generalizing so well that it knows how to handle something that we would yet. So reinforcement learning, which is the method behind most of these wins, learns by playing the same game over and over. It gets really good at that exact situation, but then it doesn't generalize enough. It doesn't carry over what it learned to a new game. And as general as large language models like ChatGPT are, they're not doing much better, even when they're trained on text and not actually interacting with the exact game environments. They still tend to fail. When you drop them into unfamiliar games, they just don't know what to do with it yet. So researchers are saying that a truly intelligent AI should be able to pick up a brand new game in roughly the same time that a skilled human would to figure it out. You know, maybe a few dozen hours, no pre-training, no custom setups. And the NYU paper is arguing that we're nowhere close to that right now. I mean, they don't have access to Mythos, so maybe they don't know about the step change coming. But as of right now, it does look like without a simplified and controlled environment, these current batch of models aren't going to be beating some of the video games that you play. All right, let's talk about some AI models that use spiking neurons. That's always kind of an interesting way to solve problems because it's so much like the human brain with our spiking neural patterns. So Purdue engineer is building a computer chip that works the same way a human brain does, so drones can think for themselves even without burning through tons of power. That's always been the big deal. If you saw my Doom kind of deep dive, where the petri dish full of neurons, the sort of brain cells were playing the game, the efficiency is like the big thing there. And when you have a swarm of drones needing to make decisions, that data traveling back and forth between them all eats up tons of energy. So that's why this researcher at Purdue decided like maybe he could fix that by copying how the brain works. So in the brain, computation and memory happen in the same place. That's why it's so efficient. So him and his team built this system with 3 parts. First, an algorithm called spiking neural networks gets set into place. So unlike a normal neural network where every neuron fires on every input, these only fire when the information crosses a specific threshold, so they use way less energy per decision. Second, it uses event-based cameras. I think we've covered these a couple times if you remember, like in the self-driving cars, but a normal camera just records everything all the time, like 30 frames a second, whatever it's pointed at. Those event-based cameras, they only record when something changes. So they kind of are more like the human eye where it prioritizes movement and kind of forgets things that are just sitting there not doing anything. And then third, there's new hardware that stores and processes the data on the same chip. So there's no more, shuttling information back and forth. So get ready to see drone swarms of things like this flying around soon with incredible autonomous capabilities. If you're looking for a more humble AI, I've got a good solution for you. Turns out some MIT researchers are working on a project where an AI says like, I don't know right now. So it doesn't like pretend it knows the answer when it doesn't. So a team led by MIT just published a framework for making medical AI more honest about what it doesn't know. And this is important because some other studies were showing that doctors will defer to those systems even when their own gut says otherwise. So if it's confident and it's wrong, doctors are just as susceptible as the rest of us to being like, oh, it seems confident, probably should trust him, not myself. But we all know why that's a problem. So instead of building AI that acts like an oracle, this team is building an AI that wants to act more like a co-pilot. Basically, they built this new AI, which is like a module that sits on top of it, and it forces the AI to score its own certainty before giving an answer. If the system's confidence is higher than the actual evidence supporting it, it pauses, it flags, and then it asks for more tests, or it recommends bringing it to a specialist. Isn't that cool? Like, it actually says, like, I'm not sure enough to give you an answer on this. I would like another set of eyes. I would like some more tests. To me, this is something that's totally missing from the way I interact with these systems. There's so much I get from when I work with like a real team in life where people, I can just sense like they're like, I'm a little unsure, but here's what I think. I did this, but I didn't spend much time on it. Like all these little qualifiers, the way our vocal tonations are, like we tend to give up a ton of information about how confident we are. So it's not really recorded on the internet or like in a transcript of a meeting in the same way. I did this, but I didn't spend much time on it. Like all these little qualifiers, the way our vocal tonations are, like we tend to give up a ton of information about how confident we are. So it's not really recorded on the internet or like in a transcript of a meeting in the same way. So I love that they're building something like this, and yeah, it's good. It's going to be good for the future. If you ever wondered why college drinkers decide they're done drinking, what triggers it, and why, I have got some information that will help you solve that conundrum. Turns out college students drink the same way that cruise control works in your car. And researchers have math to prove it. So researchers wanted to figure out how college kids decide that they're drunk enough to stop. So they surveyed 1,500 students before a night out and asked one simple question: how drunk do you plan to get tonight? Then they tested their blood alcohol levels through the night. And here's what they found out. Students who want to feel, quote, buzzed stopped pushing harder once they hit a blood alcohol level of 0.05. Students that wanted to get, quote, very drunk kept on going until they hit about 0.1. But the interesting part is actually what happened after they hit their target. They didn't just stop drinking. They switched strategies. They started sipping instead of gulping. Or maybe they used another technique like swapping in water or soda between drinks to space it out a little bit, just enough to stay at that level. Have you been there? The engineers on the study said this behavior mirrors something called a proportional derivative controller. That's basically the same system that your car uses for cruise control. I guess the ultimate goal is to build an app and like sell it in the App Store that shows you just how to like stay at the perfect level of drunk. I mean, you know, it would sell pretty well. Who doesn't want a well-timed nudge when they're out partying? And finally, what you have all been waiting for. Turns out that we might have some kind of understanding of what mechanism you can add or remove from an AI system to make it conscious. Yeah, so researchers have built 2 AI models, and they had them play a game against each other, and in the process, they discovered something about how the brain loses consciousness, and possibly how to bring it back. Get a load of this one. So, new study was published in Nature Neuroscience, and the setup is pretty wild. So they trained one AI on 680,000 recordings of brain activity from human monkeys, bats, and rats. Its job was to score how conscious a brain looks from a scale from 0 to 1. And then they built a second AI, which is a simulation of the human brain, and they had it try to fool the first one by generating fake brain signals at different consciousness levels. I think this is one of the most interesting projects I've ever heard of. Because if you think about it, now you're in a position where you can watch how the simulation had to change its settings to mimic something that's more unconscious or conscious, right? And the team found 2 mechanisms behind impaired consciousness that nobody had identified before. The first is that certain neurons in the cortex start over suppressing other neurons, which quiets overall brain activity. And then the second is a specific circuit in the basal ganglia. All right, which is that thing, the basal ganglia down there. And that specific circuit in the basal ganglia is a pathway that normally helps inhibit unwanted movement, and it gets selectively disrupted. And they validated both of these with real patient data, brain scans, gene expression, the whole works. Okay, but here's the part that matters the most. The AI also pointed to this specific brain region, the subthalamic nucleus. So this kind of Q-tip, like the sort of like bended Q-tip top thing here, it's like right before the Q-tip part starts, as the place that would need to be targeted for deep brain stimulation that could potentially restore consciousness. in someone who is unconscious. Okay, so this has not been tested on an unconscious patient, but now that there's a framework, it's like, is that the spot? Like, do you think in the future we could maybe disrupt that and people just become unconscious, or you stimulate it and they become conscious again? Does that teach us something about how you could build an AI architecture where an AI could become conscious? I mean, maybe this will just be another paper that like flies by the whole YouTube like world and science world, but like I also could see this being something like attention is all you need, some sort of foundational study that we actually get to the point of like, what is consciousness? So I had to share. And now that I shared, maybe you could go to the bottom of this YouTube video and you could share with that share button. You could even first put the YouTube video at the spot where I talk about consciousness, and then they could just watch the last 1 minute of the video if you wanted. Or send them to whatever chapter marker you think is best. But any help growing Dylan Curious, the YouTube channel, would be well appreciated. If you want to see more content like this, that is the way to help. Or you can join the community or the Patreon or any of that stuff. But either way, just leave some comments below. I love to see you guys talking about this stuff. I love to chime in and learn from the community. And we will see you in the next video.